Okay, so good afternoon, ladies and gentlemen. Now we want to check lab 3.4 on securing traffic with IP security VPN. As we've learned in the theory class, traditional IP had no way of securing the data while on transit. But now with the IP security protocol, we can be able to secure the data. So we want to see how in this particular lab. The objectives for this particular lab include configuration of an IP security proposal using an ESP transform set, so encapsulating security payload, then configuration of an ACL used to determine interest in traffic, excuse me, then configuration of an IP security policy, then binding the policy to an interface, binding the policy to an interface. So really, those are the steps that you're going to take. This is our topology. This is our topology. So the scenario, in the interest of protecting both the integrity and confidentiality of company data, it is required that the communication between the offices of the enterprise secure specific private data as is transmitted over the public network infrastructure. So as the network administrator of the company, the task has been assigned to implement IP security VPN solutions between the headquarters, which is R1. So R1 is the headquarters, and the branch office, which is R3. Currently, only select departments within the headquarter require secured communication over the public network. So here, R2 is acting as the public network. This is the headquarters branch, and this guy is the public network. So the administrator should establish IPSec using tunnel mode. So we're not going to use transport mode, we're going to use tunnel mode between the two offices for all traffic originating from the department. Not all the departments, but from a specific department. Okay, so step one is preparing the environment, really setting the IP addresses and the names for the different devices. But in the meantime, let's just label this as HQ. Then these as the internet. Then this guy here has the branch. So you can take this here. So this is the branch. This is the headquarters. So we want to create a VPN that passes the internet to R3. Okay, so let's do the basic configurations first. So we begin by the name. R3, good. Then we go ahead and configure the IP addresses together with the loopback interfaces. So we go to 001. IP address supposed to be 10.0.12.1/24. Then we create loopback 0, int loopback 0. We give it an IP address 10.0.1.1/24. So IP address. Then we go into int loopback 1. We give it an IP address 10.0.11.11/24. can do display int brief, display IP interface brief. Okay, so we can see that we've created loopback 0 and loopback 1. We've given them the correct addresses and also gigabit Ethernet 0/0/1. So we can now go to R2 and also configure those two interfaces that are connecting to the headquarters and the branch. So int 001, IP address 0.12.2.24, also int g0/0/2. We give it an IP address of 10.0.23.2 again, 24. Okay, so now display IP int brief. It's a good command to help you check that you've configured the right interfaces with the right IP addresses. So I can confirm that those two are okay. Then you can go to R3. So 002 first. Give it an IP address of 10.0.23.3/24. Then int loopback 0. We give it an IP address of 10.0.3.3/24 and int loopback 1. We give it an IP address of 10.0.33.33.24. So we can quit and do display IP int brief. So 002 indeed. Great. And now we should be able to ping the directly connected interfaces. So we should be able to ping 10.0.23.2 from there. Very well. So we can be able to, from R1 or from R2, we should be able to ping 10.0.12.1. Great. So we're able to do so. The next thing in this exercise, so generally, as we saw in the theory topic, how to configure the VPN, you have to follow a number of steps. One of them is you have to ensure reachability. So reachability, that is what we just did. Then number two, you have to identify what you call interesting traffic. That is really what you want to encrypt, and you do that using an ACL. After that, you have to establish an IPSec policy. So the policy will determine the security protocol that you're going to use, the encryption algorithm, authentication algorithm, and things like those. Then after that, you have to create an IPSec policy. And lastly, step number 5, you need now to apply that policy. Apply policy to the interface. So those are the steps that really we are going to follow here. Those are the steps that you're going to follow here. Okay, so let's look at the next step. Before that, let me just put a label here. This is lab 3 for securing traffic with IPSec VPN. Okay. So now let's go ahead and look at the next step. So after confirming reachability, step number 3 is establishing logical interfaces, the loopback interfaces. That one we have already done. Step number 4 is to configure OSPF so that the loopback interfaces can be reachable. So use the default OSPF process 1, specify the public network segment, and that one as part of area 0. So let's do that. We are going to use a different router ID. We can use 1.1.1.1 for router 1, 2.2.2 for router 2, and 3.3.3 for router 3. Okay, so generally everyone is advertising the networks that they are connected to. So that's exactly what we are going to do here. Okay, so right now as it is, we can't get to the loopback interface. For example, if our two pings 10.0.1.1, we cannot be able to reach it because it's on R1. We have not advertised it. So let's do OSPF. So we go to System View, OSPF 1, router ID 1.1.1. I normally prefer a router ID that matches the router number. So if it's R1, 1.1.1. Okay, then area 0. Then we advertise the networks. So this will advertise 10.0.12.0, 0.0.255. These will also advertise 10.0.1.0, 0.0.0.255. That's on the loopback interface 0. And lastly, 10.0.11.0, 0.0.0.255. So that was on loopback 1, the network that connects to loopback 1. So once we are done with that, we can do quit. We go to R2. R2 is connected to 2 networks. So OSPF 1, router ID 2.2.2.2, area 0, then network 10.0.12.0, 0.0.0.255. So the wildcard mask, then 10.0.0.23.0.0.0.255. Good. So quit. We're gonna check that. Then on R3, we go again OSPF 1, router ID 3.3.3, then area 0. Then we advertise the network. First one is the one that is connected to R2. So that one, 255. Then you go and advertise the network on loopback 0. So 10.0.3.0.255. And lastly, the one on loopback 1. So 330.0.0.255, like that. Okay, so we can even display this just to see that indeed we are on area 0 and we've advertised the correct networks. So right now we should be able to ping the loopback interfaces. We should be able to ping the loopback interfaces. From R2 I can do ping 10.0.3.3. So I should be able to ping the loopback interface on R3. So we do, for example, display OSPF peer brief. Should be able to see that R2 has neighbor 1.1.1 and 3.3.3 on these particular interfaces. So we've already formed the neighbor relationship. Okay, so after
Chakarit.
Yes. Go ahead.
There is one thing. If you can go back to the configuration, the question I was asking you that time on the reversal of the go back up the neighbor ID.
The neighbor ID. This one.
Yeah, up. You know, up on the configuration, not displaying.
Huh?
Just go up, please. You can that neighbor, the neighbor ID, just there, the neighbor address. You can see the change of the neighbor address. It's 1.12.0.10.
Oh, this one, eh?
Yes. Yeah, that is what I was concerned.
I see.
So it's like kind of they're reversing it. I don't know how they're coming with that reversible.
I see. There was an explanation towards this that I cannot seem to remember, but I'll research on it. Yeah, I've seen it's like they reverse it. Eh?
Yeah.
I have seen it. You see even here.
Yeah.
Okay. Thank you for
okay.
Thank you for noting that. Okay, so let's go ahead and we now check step 5 on configuring the ACL. So now we have reachability. Now we can identify the interesting traffic. So we want to use an advanced ACL created to identify interesting traffic for which the IPSec will be applied. So the advanced ACL is capable of filtering based on specific parameters for selective traffic filtering. So here on R1, we want to select packets from the 1.0 network, not from any other network. Then from R3, packets from the 10.0.3.0 network. So let's create those ACLs. So on R1 and the destination, let's also look at the destination here. So destination, this one is going to R3, this one is going to R1. Okay. So we do ACL 3001, meaning it's an advanced ACL. Then we do rule 5, permit IP source 10.0.1.0, then the wildcard mask, then destination when it's going to 10.0.3.0 and that. So we do that. Once we are done, we can do quit. Then we go to R3, also create ACL 3001, which is an advanced ACL. So rule 5, permit IP source. So we want to permit packets from the 3.0 network if their destination is 10.0.1. Good. So we are done with that. So once we're done with that, now we can go to the next step, which is configuring the IPSec VPN proposal. So the proposal will specify, so create an IPSec proposal and enter the IPSec proposal view to specify the security protocols to be used. So here we are going to specify the authentication algorithm as SHA-1 and also the encryption algorithm as 3 days. And as you can see, the security protocol we are using is OSPF. So the command to create an IPSec proposal is IPSec proposal, then the name of the proposal. So here we are just calling this tran1. So let's go ahead and do exactly that. So we need to do that on R1 and on R3. So IPSec proposal, we are calling it tran1. Then we specify the ESP authentication algorithm. So if I do question mark, you can see all the algorithms that are supported by Huawei routers. So we have stronger authentication algorithms like SHA-2 512. So they all differ in the number of keys that they use for encryption. So here we want to use SHA-1. So enter, and again ESP encryption algorithm. You can do question mark. So you can see we have the 3 days, we have the days, that encryption standard. Again, they differ depending on the number of key, and also the advanced encryption standard. So here we want to use 3 days. So enter. So once we've done that, we can quit and go to R3 and also create the same. So IPSec proposal tran1 ESP authentication algorithm. Remember, these things have to match on both ends of the peer connection. Then ESP encryption algorithm 3 days. So you cannot use different values for them. So now here, for example, on R1, we can do display IP security proposal. So we can see that the encapsulation mode is tunnel mode. The security protocol we are using is ESP, and the authentication is SHA-1. The encryption algorithm is 3DES. So that's the command to confirm that. Okay. So after creating the proposal, we now need to create the policy. So let's go ahead and create the policy. This one has quite some process because in the policy now, you have to apply the ACL that we created to filter traffic, the proposal that we've created. Then you specify the remote tunnel IP address and the local tunnel IP address. You're also supposed to create what is called an security association. So SPI, and also inbound and outbound, and also the key, inbound and outbound. So let's do this. So on R1, we are going to do IPSec policy P110 manual. Let me do a question mark here. Okay, so manual. Then security SEL is 3001. Proposal is tran1, so we created proposal called tran1. Then we go ahead and specify the tunnel remote IP. So this is the IP address that connects to the internet on R3. So that's the remote. The local is our own. So tunnel local 10.0.12.1, like that. So here really what you're doing is when you're on R1, then this is the remote and this is the local. So you have to specify the tunnel remote and local address. Okay. So let's go ahead now and configure the SPI on this particular policy. So we use the command security association. SPI is for, what did we call that? I'm trying to remember, but I'm forgetting the full name of SPI. Okay, so you have to configure the SPI for outbound, ESP 54321. Now this particular value on R1, this outbound value 54321 has to be the inbound SPI value for R3. So if you see here the background, for the inbound for R3, it's gonna be 54321. Again, for the inbound ESP for R1, it's going to be the value of the outbound for R3. So it's important for you to remember that. So after that, we can do SA SPI inbound ESP 12345. Okay, then we go ahead and specify the key. The key is just like a password to do data origin authentication, that this data really came from you. So ESP simple, the password or key that we are using here is Huawei. So this has to match again, both ends. So key inbound ESP simple Huawei. So once you're done with that, we can now go to R3 and repeat the same procedure. So on R3, we create an IPSec proposal, an IPSec policy, sorry, P1. Do we call this one policy P1? Okay. So P1 manual. Oh, I didn't give it a number. So 10 manual. Then we go ahead, specify the security SCL as 3001, the proposal as tran1. Then we specify the tunnel remote, which now is going to be 10.0.12.1. Tunnel local going to be 10.0.23.3. Then after that, we can specify now the SPI outbound. So security association SPI outbound ESP 12345 SA SPI inbound ESP 54321. Okay. Then we specify the key SA string key outbound ESP simple Huawei, and SA string key inbound ESP simple Huawei, like that. Okay, so once we are done with all those parameters, now we can run the command display IPSec policy to see the details of that particular policy that we've just created. So for example, we do that here, IPSec policy. We should be able to see that we have a policy group called P1. The sequence number for this policy group is 10. The data flow will be determined by SCL 3001. The local tunnel address on R3 is that one. and the remote one at the headquarters is that one. So these are some of the details that we can see. If I go down a little bit, we can also see the ESP SPI and the string key have also been set. So that has to match on both ends. So this was inbound ESP and also the outbound ESP setting, encapsulating security payload. So we are not using AH as the security protocol. We are using, we're not using authentication header, we are using ESP, encapsulating security payload. So we have the SPI and also the string key. Okay, so what next? So the next thing is now to apply the IPSec policy to the interface. So the policy that we've created, we apply it to the particular interface, outbound interface. So how to do that? On our topology, as you can see, we've used gigabit Ethernet. I didn't use the serial interface. So I'll have to go into 0/0/1, then IPSec policy P1. Let me just confirm that command. Yeah, IPSec policy P1. Good. So IPSec policy P1. So we have to apply that and also do here int G0/0/2 IPSec policy P1. Just a moment. Okay. So after applying, really this is the last bit. So now let's confirm. So let's test connectivity between the IP networks. So we want to, from R1, we want to ping the loopback. We want to ping the loopback of R3, loopback 1, and specify the source as our own loopback 1. So -A command. So we are specifying the source. So this is the source, this is the destination. So let's do that from R1. So I can do ping -A in order to specify the source of this particular ping. Then the destination is this particular address. So that should be able to go through. Now the reason as to why we're doing that is so that we can show you that packets from this network are not going to pass through the VPN. So if we use the command display IPSec statistics for ESP. So if we do that, we can see so far no packet. The packet count, we can see that the packet count is 0. So no packet has passed through the VPN that we just created. So no packet, 0000. So now the next thing we're supposed to do is, you remember for the ACL, we said that packets that are coming from this particular network, 1.0 network. So now we want to ping 3.3 and they are going to this network. That is what our ACL was about, the ACL 3001. So we want to specify this as the source and this as the destination. And then we do the display IPSec statistics again. So let's do ping -A in order to specify the source. So now we want to come from 1.1 and go to 3.3. So if that happens, we're going to send 5 packets and it's a success. If we do display IPSec statistics, we should be able to see that indeed 5 packets have passed through our VPN, and the ping actually sent 5 packets. So this indeed is a confirmation that packets from the 1.0 network that are destined to the 3.0 network are actually passing through the VPN. Ladies and gentlemen, that's the end of this particular lab on configuring IP security VPN. Anyone with a question, please? Okay, asanteni sana.